Re-
I welcome you all for the fourth semester. Hope you enjoyed all your holidays. Uh, this semester, it's very important semester for engineering students. Since all the prerequisite subjects we are going to study in the semester. So let us introduce our subject or the course which we are going to listen the lecture. So you all know you have something inside fueling every day for your daily tasks. Am I right? Yes. So you are giving food to your body. The body is converting it into what? Yes, energy. And this energy is being transformed to your muscles as strength. Then you are able to do the work. In the same way, all the engineering materials will have strength. So, what is meant by a strength? So, whenever a material is subjected to an external force or any internal forces, it has to withstand its shape and size and the stability without deformation. Let us take a beautiful example of Earth and the Moon. Right? We know all what is solar system, and we know how the planets and the solar system is arranged. So our natural satellite is Moon. Yes. So the Earth pulls the Moon, but the Moon doesn't come to Earth. Am I right? We are seeing at a distance the satellite. So what is the reason for that? Uh, So there is a force exerted between these two things, and it resists getting attracted, right? So I hope you all understood the analogy of Earth and Moon. Keeping it apart and at the same distance, it is revolving the Earth. We are getting light in the night. In the daytime, the sun is brighter than moon, so we are not getting light. That is what the actual thing happens. But everybody, we believe that moon goes in the night and comes tomorrow night. That is not right. Okay, fine. So we are talking about forces. So this forces uh, is not getting attracted because there is an internal resistance of the moon, right? This internal resistance offered by the moon to the Earth surface forces is nothing but the strength. It does not deform, it does not get attracted with the Earth. I hope you understood the basic thing of strength of materials. And we are going to explore the core principles, applications, and importance of material strength in engineering to enhance design and construction practices. So we just see what is the overview of strength of materials. As we said, we start with the definition. Strength of materials studies how material deforms and fail under loads. So that is a basic thing when you apply a load on particular object, how it deforms and how it fails under load. So in the left hand side, we have see a drill bit, a drill chuck holding a drill bit, and it starts rotating clockwise in the material. Rather, it's not a drill bit, it's a, yes, it's a milling tool, right? It's an end mill uh, machining a surface or removing the material which is to be machined, right? So the forces acting on the end mill makes the end mill to rotate at a higher RPM, and we are since the workpiece is strong, harder than whether the workpiece is harder than end mill or the end mill is harder than the workpiece. Yes, always the tool is harder than the workpiece, so that the material deforms the workpiece. The second essential is structural integrity, ensures safety in buildings, bridges, constructions through material performance and analysis. Material selection guides engineers in choosing appropriate materials for specific applications. Predicting material behavior, fundamental for forecasting how materials react under stress and strain. So we go into this core mechanics to understand the fundamental concepts. Stress is nothing but the internal resistant force per unit area with the materials typically measured in pascals. And strain, whenever there is a stress, there is a strain. Deformation experienced by the material in response to stress, expressed as ratio. And the one more property is elasticity, the ability of a material to return to its original shape after stress is removed. Plasticity, permanent deformation that occurs when stress exceeds yield strength. Failure, the point at which material can go no longer withstand applied loads, leading to fracture, that we call it as failure. I hope you understood the basic concepts of materials. Hope we'll see in the next lecture in detail. Thank you.